Welcome to the fifth section of the Reactive Microservice Design course. In this section, we will continue to explore the value that any reactive microservice architecture offers. Building on the foundations of the previous section, we will explore the responsiveness trait that reactive microservices have. Mainly, we will cover responsiveness, maintainability, and extensibility. Let's introduce the core values of reactive microservices. In this video, we will introduce the core values of reactive microservices, which are responsiveness, maintainability, and extensibility. Responsiveness. A reactive microservice responds in a timely manner, if at all possible. Responsiveness is the cornerstone of usability and utility. But more than that, responsiveness means that problems may be detected quickly and dealt with efficiently. Responsive systems focus on providing rapid and consistent response times, establishing reliable upon bounds so they deliver a consistent quality of service. This consistent behavior in turn simplifies error handling, builds end-user confidence, and encourages further interaction. Maintainability and extensibility. Once you introduce a microservice architecture in the project, introducing change is cheap. It is known at start that the inner implementation details are shielded from the outside, and therefore one can safely refactor without the danger of breaking all the components. It is now also possible to replace runtime, language, architecture of a single component without forcing a full architecture change to the whole application. Let's talk now about extensibility and maintainability. Let's go back to our monolith application. Let's make a simple request like we did before. Let's look at this request. If I execute this request, it works as expected. I create an account with a balance 10. But now imagine that someone with bad intentions would create an account with initial balance of -10. It still works, although this might be a bug, because you don't want to create an account with a negative saldo. In this case, this would raise an alarm bell in your business and you would need to fix the application. You would need to go to the account controller, inspect the code where the accounts are created, here, and probably introduce some validation. What you would probably do something like this. If account balance less than 0, we would do a response, send error, bad request, and stop. And this is fine until you notice that now that in order to fix this small bug, you need to introduce downtime. And why? Because first we need to build the application, and that doesn't introduce downtime per se. So we do again maven clean package. And as you can see, the application is built in the background. And now you need to stop the application. And of course, this will not be responsive anymore. And start the application. Because everything is on the same code base, everything is in the same monolith, even to fix something that is really isolated that you could control yourself, you need to restart the full application. Of course, this will again introduce downtimes and your SLAs will go down. Maybe your customers will not be happy with the waiting. You'll probably get some complaints about that the service is unavailable. In a reactive microservice architecture, you would be able to stop only the account service and the rest of the application would still be available. Of course, if you would be even more fine-grained, you could stop specific endpoint, if that would be just the microservice you were talking about. So once you implement a microservice architecture, you can have full control on what can be stopped and upgraded. And now let's imagine a second scenario when we think more about extensibility. Let's imagine that every time you create an account, you want to collect some data metrics. This would mean that you would need to go again to the same piece of code, here, create account method, and implement your business logic here. So you would need to go here and now say, let's collect metrics to a second database. Once you would implement this code, the same would happen. You would need to stop the service, deploy the application, probably add more dependencies on external services, new databases. Once you switch to the reactive microservice architecture, all the code changes are isolated behind the service interface. other service will not be aware of the internal implementation details, and you can just change at will as long as the interface remains the same. So as long as the meta signature remains the same, everything will be working for you. Let's understand how responsiveness works by creating a dummy controller which only role is to sleep. So let's create a controller here. I would create a new class, right click, new Java class, and let's call it the sleep controller. So this controller will need to be annotated with annotation controller. And now we make a very simple request mapping. So let's create now we need to annotate it so Spring can map between a HTTP request and the code. For this we use the request mapping annotation. Request mapping. And we say it's a HTTP GET to keep it simple. Now we have this application now. We can now rebuild it. And to rebuild, use command maven clean package. So what is so special about this code is that when we generate load on this controller, we will exhaust the application threads, leaving the application unresponsive. So let's test it. In order to generate load, I will use a tool called worker. In the worker tool, we specify the amount of threads and the amount of connections you want and what's the request you want to use. So let's do this. I'll do worker using 8 threads. And we'll create 800 connections. So it will be really busy. And we will run it for 10 minutes. So we can have it running on the background and to not worry about it to be stopped. So now we specify the URL, http localhost sleep. Of course, we first need to start our application. So I will use a second tab here. Let me create a new one. I will do docker compose up. The application is started. So let's run again the worker. It's working, doing its stuff. So now let's again try to create an account. We create an account by doing exactly the same request we did before. HTTP post to localhost/account with initial balance of 10. As you saw before, this method would return really fast because it's just creating a row on the database. But now nothing is happening. Our application is not responsive. And it's not that there's lots of load happening, it's just because all the threads are sleeping. So this shows that you can quickly get an unresponsive application in a monolith architecture. And this is quite bad if you are front-facing application to the public, where the time people need to wait for the response is quite important for your business. So as you can see, monolith applications that do not use a reactive architecture will not be responsive. A reactive architecture will be responsive as it is specially crafted to handle both the load and resources of your machine in an optimal way. You should now know that a reactive microservice gives you responsiveness, maintainability, and extensibility.